classical model, classical version, classical exponential, classical version of the exponential smoothing method. Alright, so single or simple exponential smoothing implementation of single exponential smoothing method in R can be performed using SES function available in forecast package. So you have to install this one person, you have to install forecast package. If you haven't installed, you have to install forecast package. Otherwise, you cannot use the given function or command SES function. So using the same data, we have to import, open the RStudio, use RStudio. RStudio is this one. How are you able to see this one? I don't know how to do. Okay. Okay, so we need to import data, so I save on desktop this one. So you go to File, Import Dataset from Excel. Okay, and then just okay. So File, Import Dataset, Excel. You browse and locate the file where you save the file. So I go to desktop, I save on desktop, exponential, this one. You save the top drive, then you look at the top drive. Okay, the folder, the file in the top drive. Okay, and then just and import. You go down and then click import. So in order, I hope you have already listened to the recorded explanation on how to use R. Okay, so if you import data, so you have data in Excel file, and you want to analyze each of these separately, so you have to use attach. There are many ways. So one of the ways, if you use attach function, attach that variable. So you can use attach and then name the file that you download just now. You can type, I just want to save time. I just copy and paste dash key and press enter. Type the one dash, and then now you can see the variables that you want. You can what we call it, inspect variables separately. For example, you can type with opener, for example, and then you can see, you are able to see the values. That's all. This one, the title, you type, then you're able to see. Now, because our data has different length, okay, so we need to first we want to convert each of these series into times data, because in order to use forecast package, the function available in forecast package, need to it can only be used on times data because the data that you have just now is not in form of time series data. It's just a series. Okay, so we need to convert it and tell and so that R know the software knows whether it is what data monthly or quarterly or what point or. So you need to. So we create a time data. So we use this data as opener, and then we use data from the first up to the last one because the data is not. We just want to have data from here, number 1 to number 11, number 1 to number 11. Okay, so and then you type the name of this series in order to see the values, and then produce graph. This one you can type about it, but again I want to save time. I just copy and run it 3 together at the same time. But later you can do one by one. You can copy this one by one. So we convert into times data, and then we type the name and then produce graph. Press enter. Too big. Okay. So this one times data. I do the plot graph, the plot. Oh, so this one we need to. Okay. So this is the graph of the series. So that's the data. Okay. Now we need to have this. I mentioned before. So for time series for this course, basically we are going to use a number of functions or commands or functions provided by this package. Okay, so basically package just like book I mentioned before, just like book. You need to install or you need to get a book installed. You need to install to get a book and install within that book. It has a number of functions that we can use. Every time we want to do the function, we have to call that package. We have to get that book so that we can get the function inside that. So we need to every time after you install package. In the video, explain right how to install package. Have you watched the explain right how to install package? So I hope I explained the recorded lecture, recorded video. If you haven't installed, then you have to install it. So you go to tools, you can, install package and tool, install package, and then you find that one. But I think we already have that one. I already have that installed, I believe. So let's try to type this one. So call that book from library. Call that package from our library. Okay, meaning that there's no error. That means that I have in the library. I have that application in the library. You have any error, that means you haven't installed. You have to install all package first. Okay, that's what I did. So you don't have. You go to tools. Then you can install package and then you type forecast and then you install it. Okay, now we want to apply or estimate SES, simple exponential smoothing. We can use SES and we can use SES function provided in forecast package. So how to use it? You can just type SES and then just type in bracket the variables. So this one, if you use the SES just like this, then it will estimate the parameters as putting constant by minimizing the subset of error. Okay, optimization. So meaning that you ask the function to estimate instead of assign a value. So let's say SES opener like this. Just press enter. So it produce forecast, it produce. So this one it produce forecast, but you want to get the details. Basically, you can use summary. So alternatively, if you want to save the estimation result, you can put any name. Let's say you can put like this. You can name the output as opener underscore SES, so that it will save that. It will save that. It will save the every time you want to see the estimate, you can just type this one. Because sometimes if your data is too large, it will take time to estimate. So in order to not to waste time, you just want to estimate once, and then later on you just want to see the result of the estimate. You can just type the name of the saved output. Okay, this is how we save the output. You name it and then you this one. And then you type as you read this one to see the. I mean, you produce the same. You produce the same forecast values and forecast values. And if you want to get the more details, more information, you can use summary of this. So it will tells you that the models, you use summary, and then it tells you what model, the estimated alpha, small value 0.000001. Then initial value of level, this one. Yeah, I see as well, and then the measure as well, forecast. Now, if let's say this one, it will calculate by its own, by default, the number of how many static forecast. But if you want to produce certain number of forecast, then you can specify. You can if you want to produce certain number of forecast values, then you need to put here this one. Here you put h equal to what? For example, here also can. So you put, you cannot. You need to put here. So SES, let's say h equal to what? Equal to 5, for example, and then you will only produce forecast for the next 5 equations. Okay. How to know? I mentioned before. I mean, you listen to the given video. How to know what details of the function? You can type question mark SES. SES. You press enter, then it tells you how to use. You can go to this one. You can go to. I think you click. I can explain. SES, and then if you can put H or the default 10. You want to change the number of forecast, then you can change. You put comma H equal to what? How many forecast value you want to produce for the next one? Okay. And then you want to set. Okay, this one is the next example. You want to set alpha. Alpha any value. Let's say you want to put 0.5, then you put here. Okay. So let's say, okay, plot, we have a good plot forecast. I think the good thing, I mean, one of the advantage over if use, I think I mentioned now, so different software has certain advantage and disadvantage. You produce plot, and then you give forecast or the plot forecast. So SES just flat forecast, remember? SES just flat forecast. Because it is suitable for horizontal pattern, trend pattern. Okay, now if let's say you want to assign any value, instead of asking R to estimate the constant, you want the alpha to be a certain value, 0.5 for example. By fixing the value of alpha, then you can put like this now. You can put comma alpha t equals certain value. So, but remember this value is supposed to be in between 0 and 1. Okay. So this one so the variables SES, the times data, and then alpha 0.5, press enter, and then you can type, because we save the output using this name, you type again that name, and then it will show the outcome, the output. Basically output is just for current value, but you put summary that is that one, and then it tells you what's the value of, alpha of course 0.5, but the initial value for level as well. If you want to know, you can use summary of that. Summary of the saved output. So you have alpha 0.5, the state 185, and you can produce plot as well, just like before. This one I didn't put. You want to do, you can put a plot the same one, using the same plot, the same output. Now, if let's say we want to, okay, so for the previous two, if you choose to do like this, it not only estimate alpha, but it also estimate initial values. Okay, it calculate the initial value of level L1, or in this case R, L at time 0, L0. It calculate that using the heuristic scheme explained here, initialization is 1. Okay, for the level component is calculated using this. This it calculate for initial value, but when we estimate, it will also find alternative value that provide the smallest error, as I see, smallest error, the smallest error. So meaning that initial value also can be estimated. Okay, but if we want the initial value to be estimated, meaning that we just want to use this one. This is the estimated initial value, and we don't want to change the value through optimization. So when we estimate, we just want it to estimate alpha very constant only. We don't want to change this value. Okay. So again, previously the previous two, this one when we simply put SES, or we just put alpha 0.5. For the estimation, it also estimate the optimal value of initial value L1, L0, not L1 but L0, that gives smallest error, size of error. But if you want to estimate the initial value, meaning that we just want to just use this one to calculate initial value, and then just use this one without no need to estimate, and then you have to put like this lah. So you put initial simple. Okay, simple. You read just now the explanation. Okay, you read the explanation. You type the question mark SES, and then you read that. And you put simple. Just use the heuristic scheme. Heuristic scheme of estimation. Based on heuristic scheme explained here. This is a heuristic scheme. Okay. So we put like this. Then I just copy everything. So you don't worry about this one, because if you put this symbol, it will ignore everything after that. It will ignore everything we type after that. We will write after that. So I can just simply copy everything and paste everything. So if you want, I just put notes for you to read. To help you to understand. So we have, okay, you can see. So initial state 200. Okay, so you just and then select estimate of alpha 0, and then the initial state through the heuristic scheme 200. You just take the first value, first value 200, right? Our first value 200. So L0 equal to Y1. Okay, next, hot linear try method. Hot linear, you can use hold function. So you can use HOLT. Okay, so basically the step same, you just put hold and then bracket the name of the series. So this one, because just now when we import data, we import that some of them has no value, so any A. So we need to choose the part of the data that we have, the part of series that only has data. So the first one until 24, so 24 observation. So frequency 12, multi data. So plot and so on. So maybe I just copy up to this one first. So basically you need to do one by one. I need this one by one, but again I want to save time. I just run more than one. We call a function. At the same time to save time. I copy this model. So basically, so for a second, I convert inventory data into time data. So now we come time data, multi data, and then plot of the series. We get this one. So it has time. So we assume that there is no seasonal. Okay, based on the graph. So we can use whole linear. Whole linear, how to use? You hold and then this one. Either you just put, either you just type this one to get result of you produce forecast. You provide the output, just produce forecast. So you just based on the forecast value. One step in for our sample forecast, one step in, two step in, three step in, and so on. But if you want to save the output, then you do something like this. You put the name equal to this one, and then you save the output in within this using this name, and then when you type this name, then you can see the. Okay. So I mentioned before, if you have very long data set, it will take time to do the estimation. So instead of wasting time to estimate every time you want to see, you just save and you save the output. So that later on you want to see the result, you just type the name of the output. Okay. So just now I paste up to this one, right? Okay, so now I paste this one and produce plot of forecast summary to the details. Okay, so it produce forecast alpha, beta, estimate alpha. You put summary, you get alpha 0.3, beta small value 0.0001, initial L0 not LT, L0 B0. R is start from 0, 1 is the value. If you I'm not sure if you whether 0 or 1. The one that given. I haven't investigated this one. Because I used to work on this using what we call the framework given in the book. I mean the information given in the PDF file. Basically, we calculate value for time 0, initial value. Forecast. So this one, if you want to change the forecast period, how many step in forecast, then you need to put here. So you can add H equal to what? Comma H equal to. Let's say you just want to produce forecast for the next 6 observations, you put comma H6, and then you only produce forecast for 6. For the next 1 step 8, 2 step 8, 3 step 8, 4 step 8, 5 and 6. Okay. You can just set. If you want to set any value, you put like this. Alpha 0.5, beta 0.2, or any other value. But it should be between 0 and 1 for both beta, alpha and beta. Okay, so just now so the forecast value and forecast and then the plot. So if you want to set any values, you put like this, and then you get. Okay, so 0.5, 0.2. Initial state, 147, L0, B0, 03301. For winters seasonal, you can use HW. Okay, HW. So you put additive for winters additive, you put multiplicative for winters multiplicative. This one, huh? So you use the same function HW for winters, but whether it's additive or multiplicative, you have to put here. You have to specify here seasonal equal to additive or multiplicative. So you want to know detail, you can just type question mark and then type HW. Question mark HW, and then you see how you can use that function. So this one, I just copy everything. So alpha 0.8. So this one 0.8 quite similar to Excel, right? As a solver. You compare later on, you can try to reproduce and compare the estimate and this one, and you use the in terms of the value. I think it's quite similar to the one we use in Excel. Forecast value, plot of forecast given here. So again, you also can change how many step minutes you want to forecast. Just put H equal to 1. For winters multiplicative for inline data, so you create time series data for inline data using TS function, and then use HW and then specify multiplicative for winters, and then you produce forecast and plot. So you get this one, your forecast. Okay, you forecast, and then you get your terms of graph. So you provide the graph forecast. Stage page. ETS. So implementation of ETS exponential modeling method in R can be performed using ETS function. Again, also provided by forecast package. So data is just the same data. So library forecast, we have already done this one. So you can just this one also we have already covered. So you can use ETS. So this one ETS, the name of variable, and then you need to specify order equal to what. So this one A and N for the simple, which is equivalent to simple exponential modeling. So it is ETS E and N. Additive error, no trend, no seasonal. Okay. So you can just copy from here. Okay, so I mean later you compare at home, you can reproduce but remember, I think alpha is same, but beta classical version and is not equal to beta in the ETS model. Remember, it's different because beta in ETS equal to alpha times beta in the in the as a classical version. So you get your forecast. For the case of the model that's equivalent to whole linear, so ATS AAM. Okay, for inventory data, you put the model AAM. ETS, the name of series, model AAM. So this one, to produce forecast, you have to use this one, forecast. So unlike the classical version, when you put the name, it automatically directly produce forecast. But this one, it does not. When you estimate the model, it does not produce forecast immediately. It just show the model. ETS, the estimate of alpha, beta. It does not provide the forecast, but you need to, in order to use forecast, you have to use forecast function. Forecast, the name of the model, and then use forecast. So slightly different way, or slightly different step. For this one, inventory data, forecast and plot. AAM. So our forecast AAM, alpha, beta, the optimal value, initial value of level level L0 and B0, and then we have our forecast. The default, how many years? 2 years. The default as how many step ahead is 2 years. But you can check now. You just want to have for 1 year, you put 12, age you put 12, comma, age 12. Forecast. So for winters, you can use ATS as well. I mean still ATS, but you have to model AAA or AAM for winters. This one additive, manipulative M. But you notice that I put M here for error because you put additive error, it will not are unable to estimate, but it used to be able. So certain model it prohibit. I do not know why. So this one, okay, let's say we do this one first. So that's why we have to use more. That one sometimes we cannot get the estimate using. Then you can use. This for winters additive. ATS AAA. Plus for winters as manipulative is one. I put MAM. Later if we try EAM, what happen? Okay, so for the airline data, so if let's say I estimate using AAM, what happen? Here I put ATS airline model AAM. So let's say put A. I cannot. Forbidden model, I don't know why, but you can get this model in EViews, this is airline data. You go to view a prop, exponent, smoothing, ATS, A, additive, AM, right? AEM. Okay. So ini you get 0.7 but beta 0.0. Yeah. But in I cannot probably model combination. For the case of but use manipulative error MPM. And if you just want to, you want the function to select model for you, no need to mention. So this one you specify what model into what. But you just put the series and then the function will find model for you. Okay, what is it? You compare all possible model and then compare the criteria like AIC or whatever, and then you can choose whether to select model based on what. If you you read the details of the function. So this one you put ETS, the name of series, and then you propose a model for you. Okay, so without stating the model equal to what, you just put like this. So it's just for Elang data variables. It's just M and M. So multiple error. No, this is Elang data. This is wholesale. Oh, okay, it's not Elang data. Wholesale data. So no trend and multiple seasonal. Multiple seasonal version. So now it just multiple because it's not exactly equal magnitude of the seasonal. So based on model selection criteria, it is smaller for the case of multiplicative seasonal version. So please try to reproduce this again at home and make comparison and compare reviews and R. The forecast package is created by the same person, the same author, and the one that produced, who come up with this classification, the ETS model. But then later, it also appears or available in reviews. So reviews many different person who created the what we call that, the estimation step or procedure. So basically. Okay, I forgot to explain one thing. If you go to this our online textbook, you go to this one, exponential coding, taxonomy. In this textbook, there are only 9 classification. The later version, the third edition, instead of 15 just now we discussed, there are 15 types of different classification, right? But in this book only 9 because they have removed the remaining 6. Okay, why? Because it's mentioned here. I think mentioned somewhere. Okay, now the first edition, second edition still have 15. Second, I think, but now third edition of the book they remove it because why? We do not consider multiple trend because they notice that the model with multiple trend tend to produce poor forecast, so they exclude the multiple trend. They only use non-additive trend and additive. But in use we still have in use. So I'm not sure about the code ETS in R whether they have already updated by the same person, the same author who produced or produced this book. Okay, but in use we still have. In use we still have for all 15. So we have trend we still have 5. Even multiplicative and as well. Yeah. Alright, I think that's all for today. So next week we discuss how to characterize cycle. The next session we discuss next week. The lab session 3, I think.